Hey again guys, and welcome back. In the last video we assembled Gadget Reboot's 555 timer dev board, and in this video I'm going to try to make it work. Now I may have misassembled this, so this could be interesting. I may have messed it up. I hope not, but we shall see. So the first things first is we've got a ton of these pin headers on here. And Gadget Reboot has sent a whole bunch of these jumpers. So we need to jumper a few of the connections in order to make this function. So if you're interested, you can go to this GitHub and you should be able to find everything, schematic, jumper usage, etc. But because Gadget Reboot, I guess, felt I was a VIP, he sent me this sheet. This is the circuit diagram, so you can take a look at that if you need to. And he also sent these jumper positions. I'm not sure if you can see it on your screen, but there's a few ways to use this: monostable, astable, and variable duty cycle. And there's these miscellaneous jumpers. So down here you see that J1, if you install the jumper on J1, it'll just run in normal mode. If you remove it, then you have a reset that you can use externally. J3 and J4 brings cap C2 and C3 into circuit for timing. If you remove it, you can use external timing. And J10 is just power on, power disconnected. So I think what we're going to do is install J1, J3, J4, and J10 to get this into sort of like a default starting up mode. So there's J10. Put that jumper in there. J3 and J4, they have to forgive me, I'm a bit far from this, so my eyesight's not that great. I'm standing about a foot and a half above this. J, was that 2? There's J3, so J3, J4, it's actually quite intuitive. And we need J1 for the reset, so J1 over here. Alright, well, that's good. So now, monostable mode, you get a one-shot triggered output pulse. We could do that, but we need to move the trigger pin from high to low. So it needs an external pull-up and switch to ground. So I think we won't do this one. We'll skip to the next one, the astable oscillating mode, which is the mode that I feel that hobbyists that are just starting out, like myself, we use the 555 timer in astable mode most often. So J2 needs to be installed. J2 is down here. There's J2. J5, so it needs to be installed between pin 2 and 3. So R2 and dis, so right here. Very nice. And J7 needs to be installed on R1 and dis. So J7, R1 and dis in this position over here. Now the last thing is I need to power this thing, and this thing can actually be powered between 5 and 9 volts. So I'll actually use this power supply. I'll set it up. I'll set up the oscilloscope, and then we will do our first connection together. So if it catches fire, you guys will get to see and judge me, of course. So I'm just getting ready to go here, and I figured I'm going to have to use the oscilloscope for this, but if I use my power supply here to give me power and ground, I don't really have a ground for the oscilloscope ground. So I went to the schematic, and thankfully Gadget Reboot has sent me the schematic. I can see that pin 1 of the 555 is tied to ground. That doesn't help me, it's a surface mount component. C1 over here also tied to ground, but that doesn't help me very much either. But I see C2 and C3 are also tied to ground, and they have slightly longer leads. At least C2 does. So I'm going to see if I can hook onto that. But if I can't hook onto that, I'm going to have to figure something else out. Yeah, that's a bit tight. So what are my other options for ground? C5 and C4. C4 is here. That doesn't really help me. And I don't see a C5. Oh, C5 is that surface mount part. How about our jumpers? Nothing much there. Jumpers over here. Nope, no ground here. There's a ground after the diode, but the diodes are surface mount, so that's no good. So yeah, I guess if I could do one criticism is that there's not really a good place to ground out my scope. So maybe I'm going to try to figure something out with the ground pin here. But other than that, I'm kind of screwed. Alright, so I officially have my first bodge. I've got a little wire here soldered to the ground pin underneath so I can ground out my scope. I got my scope on the output pin, so that's the third pin from the top. Pretty sure the 555 timer pin 3 is output anyways, so well done, Gadget Reboot. Oh, gotta put his little sticker there so you guys can see it. 9 volts here, and I also have a 1 amp current limit, so if this thing decides to blow up, it'll blow up spectacularly. Got my wires here, so 9 volts, 1 amp maximum on here. Got the oscilloscope set up, which I'm going to put right here. And now I guess the only thing left to do is to give it a shot. So here it goes. Okay, this LED's on solid, but as you can see on the oscilloscope, we are getting a trace. So let's see if I can mess with the time base. Okay, so it looks like we need to adjust some of these pots here. Let's see, R1 and R2 they said on the paper. Oh, seems to be adjusting the frequency. So the way it was, oh, it's gonna spin it this way. Oh, there we go, we got something now. 140 hertz or so. I'm opening this up. Frequency is now too slow to count on this time base. Keep going. Okay, what about R2 now? Oh, R2 seems to be affecting the on time here. So R2 is the on time, and R1, yeah, looks like it's the off time. Actually, no, sorry. R2 seems to be... Yeah, R2 is the on time. I'm not quite sure. I'm not well versed with 555 timers enough to determine what exactly is going on at the moment where it's happening. I'd have to look at the schematic. But it looks like I'm moving R1, and the off time is not changing. The on time is. When I move R2, the off time is changing, but so is the on time. So one of these must be frequency. The other one must be like through the discharge cap. So that's interesting. What does R3 do? I don't think R3 is in circuit because it's not doing a darn thing. Okay, that's quite interesting to see. So this actually does work to do something. The red LED is not doing anything. I'm not quite sure if it's supposed to. I should really have gone onto the GitHub, but you know, I don't like that website. It's a little confusing, for me at least. For you guys, it might be fine. So that's good to know. Awesome. So let's set up our jumpers for a different configuration. Next one I want to try out is the variable duty cycle mode, which is the oscillator. J2 doesn't move. J5 needs to move from 2-3 to 1-2. So J5 here to 1-2. These are very difficult to remove as well, but very doable. They do sell jumpers with handles on them, which I think would be another improvement for this kit. But at the same time, he sent this to me for no cost, so I mean, I have no issues buying my own jumpers. J7 pin 2-3. So moves from 1-2 to 2-3 on J7. Whoops, did I do this wrong? I think I had it actually wrong for the astable mode oscillator, so that's probably why it didn't work exactly like I thought. But that's fine. This one here will be fine. 2-3. See, you can never trust. No, you see, it's supposed to go between dis and d percentage. So actually, it's just because this header is flipped and the numbers are not quite in order. So it is 2-3 is actually these two because it's supposed to go between dis and d percentage, which is what it's written here. So that's fine. So they were in the right spot, and now they're in the right spot for this one. Great. So now all I need to do is hook this up, hook up my scope, and we will see what we get. Okay, I think I'm all set up. Just going to put the oscilloscope up there, and let's give this a shot. Okay, so immediately we see our LED is flashing quite slowly. R2 controls the duty cycle and R3 the frequency. If you look here, sorry, R3 is duty cycle and R2 is the frequency. So let's see if we can increase the frequency here. These are 10-turn pots, so they may take forever. Oh, that's all the way. Okay, let's just change the time base then. There we go. All right. And maybe I'll put this into roll mode. It might be easier to see. There we go. I think that's a little bit more visual. So let's change the frequency in the other direction. Okay, it's becoming quicker. That's interesting. I'm going to move it back to its minimum frequency. There we go, that's the minimum frequency. And now I'm going to change the duty cycle. So this is by moving R3. Oh yeah, we can see the on time is definitely getting smaller. We're not getting 100% off here. Let's go the other direction. We are seeing our on time get bigger and bigger. Are we going to get 100% on time? I don't think so. I think I'm at the end now. And look at that. We have our maximum on time now. So that's pretty interesting. I do like that there's a little LED here that shows me what's going on, so I don't have to rely 100% on having a scope plugged in at all times. So yeah, this is a really interesting little kit, and it's perfect to have around on your bench to just give you a quick and dirty pre-built 555 timer circuit, so you can use it to trigger things like MOSFETs or transistors or relays or anything really. I do like that the frequency is quite low, which means that it's perfect for a beginner that doesn't have an oscilloscope. So you can actually track what's going on with the LED instead of an oscilloscope because it's slow enough. Also, this kit was extremely fun to build because it had some more challenging and some less challenging parts. And honestly, these 555 timers can be used for virtually anything. So to have something that you can move the jumpers around to have different settings is really the ideal, especially if you're into learning. So with that being said, I want you guys to head over to Gadget Reboot's channel. There's a link in the description below. And thank him for sending me this kit. And tell him that you came to his channel because you saw him on here. I think that'll be it for this little kit. Please stay tuned. I got a lot of cool videos coming. And thanks again for watching.